Have you ever wondered how advanced artificial intelligence models manage to understand the nuances of language or complex data, even when words are far apart in a sentence or elements are distant in a sequence? How do they connect seemingly unrelated pieces of information to form a coherent understanding? The self-attention output representation is, at its core, a refined numerical vector for each element in your input sequence, enriched with contextual information from all other elements. It is not just a simple re-encoding of the original input. Instead, it is a sophisticated, context-aware numerical fingerprint that holds the essence of that element's relationship to every other part of the input. This rich representation is vital because it allows the model to capture intricate dependencies and subtle meanings that would otherwise be missed, forming the bedrock for deep understanding. This powerful representation emerges because the self-attention mechanism specifically computes an alignment or relevance score between each element and every other element in the input sequence. For instance, when processing a word in a sentence, self-attention looks at all other words to determine how important they are to understanding the current word. It then uses these scores to create a weighted sum of the input elements, where more relevant elements contribute more significantly to the new representation. This process allows information to flow freely across the entire sequence, effectively capturing long-range dependencies and making the output representation highly informed by its surroundings, regardless of their original position. Practically speaking, this output representation acts as a much more informative input for subsequent layers in a neural network, such as those found in transformer architectures. By providing each element with a representation that already incorporates global context, models can perform advanced tasks like machine translation, text summarization, or even image recognition with far greater accuracy and nuance. This context-rich vector allows the model to make more informed decisions about the meaning of words or features, enabling it to generate more coherent and relevant outputs. One of the key insights here is the use of query, key, and value vectors. Each input element generates these three distinct vectors. The query vector searches for relevant information, the key vector describes what information it contains, and the value vector holds the actual content to be passed on. The output representation for an element is essentially a weighted sum of all the value vectors, with the weights determined by the compatibility between the query of the current element and the keys of all other elements. This dynamic interaction allows for an adaptive focus on the most pertinent parts of the input. Ultimately, the self-attention output representation provides a dense, contextually grounded numerical snapshot for every piece of data it processes. It is the sophisticated way deep learning models integrate global information, allowing them to form a cohesive understanding of complex inputs and unlock capabilities that were once beyond reach, significantly enhancing their ability to learn and generalize across diverse tasks.